we start the pre-recording for today's class. The idea for a transistor is that any transistor in a circuit will look like this. It can show up in any orientation, but there will be a circle. There will be a circle. There will be a flat surface coming out one end, and there will be another end like that, and one of the ends should be given an arrow. Here, this is called the collector side. This is called the emitter side, and this is called the base side. The idea is that whenever there will be even a slight amount of base current, the collector current and the base current will join up to produce the emitter current. How much current will flow through collector to emitter is directly related for how much current is allowed to the base current. We have seen the atomic level discussion for this by some animation last class. So I'm not going to get into detail for that. We're going to see how can we use this component for our advantage in multiple of the cases. Now, before I get into this, I'd like to discuss a couple of things with you as well, which are the logic gates. So logic gates, there are actually quite a good number of logic gates, and multiple and combination of multiple of those can give us a whole lot of a whole lot of different type of logic gates. But primarily for your syllabus, you have to learn about 3 logic gates and 2 combination gates. I'll show you what this means. You can find out the logic gates diagram and their truth table in the book. There is a certain page number. During the fair book to turn over, there is a good figure. What you need to remember / learn / memorize is the shape of the logic gate and the type of behavior they do. So the first logic gate is the NOT gate. The NOT gate reverses the logic. Reverses the logic means in binary world, we have 2 basic digits. We have 1 and we have 0. 1 is named as on, 0 is named as off, or 1 is called the high voltage, 0 is called the low voltage. 1 means current is flowing, 0 means current is not flowing. So it goes in that way. The high voltage, low voltage definition is more commonly accepted. So if it ever shows up in the exam, you better write the high voltage and the low voltage part. So a NOT gate simply reverses it. A NOT gate symbol, individual NOT gate symbols like this. There's a triangle. In front of the triangle, there is a circle. This circle is the basic symbol for the NOT gate. And when it comes out, it gives you 1. So if you have 2 things, let's say if you have input A and then output as to B, then as A will turn, if you imply high voltage over here, you're going to get low voltage over here. If you apply low voltage over here, you're going to get high voltage over here. It will simply reverse the digit. That is one purpose of the NOT gate. The main part of the NOT gate is this circle, because this circle will be used later on for other combination parts. You have to remember the shape of the circuit symbol. This is the circuit symbol for a NOT gate, not any rectangular stuff. Pretty much like battery, resistor, variable resistor, switches. They have a very specific circuit symbol. This is the circuit symbol for a individual NOT gate. The second gate that we have to understand is what we is called the OR gate. OR gate means, OR gate means either input 1 gives 1 output. So basically the name itself says, it says OR gate, which means anyone would do, which the shape of the OR gates goes like this. Let's say this is the OR gate shape. So we have, this is a shape. So you have a curved input, concave input, and then we have an arrow shaped figure, but the sides are also slightly curved. They are not straight lines, and the point and the end is pointy. Borat, pointy. Borat কে কে দেখছো? Like ever in life?
ওয়ার্ডটা মানে কি?
Borat.
দেখার প্ল্যান আছে।
আচ্ছা। Don't see Borat 2 before seeing Borat 1. Acha. And see it alone. I mean, this is something that I should be prescribed for your own safety. If you're trying to see it, it's better you see it alone. I mean, this is not a family movie by all means. But it's very
gives output 7.
কি জিনিস?
এই যে ব্র্যাকেটে যেটা লিখেছেন
এটা
Yes, sir.
হ্যাঁ বলো
বুঝিনি।
either input 1 gives 1 output না আমি এটা এখনো বুঝাই না আমি ট্রুথ টেবিলটা আঁকতেছি
Okay, sir.
sure I'm not gonna need 4 columns. I'm not gonna need 4 columns. I'm not gonna need 4 columns.
স্যার লাস্ট ক্লাসের লেকচারটা কি আপলোড করছেন?
না লাস্ট লেকচার আপলোড করা হয় নাই আমি ভুলে গেছিলাম আমি আজকে ক্লাসে পরে আপলোড করে দিব আচ্ছা এখানে ভুলে আমি একটা বক্স বেশি করে ফেলছি but still I'll keep that box over here because I might need that later on so what I'm gonna do I'm gonna save keep this box because I'll be needing this 3 more times let's copy this even okay so here comes the truth table for this OR gate the OR gate works whenever either of the input is 1 it gives an 1 output which means if these are the two sides A and B in this case are our input sides we're going to feed this logic gate voltage through these input sides these are two connector points and C is an output points so I'm going to write over here A B this is going to be something that we are going to provide and C will be the output in this case we are not going to need the fourth column so might as well cross this out the way it works any of the input being 1 gives you a 1 output the typical way that we go for the description for the input side is like this we can give 0 0 you can give 1 0 you can give 0 1 you can give 1 1 you can use any of the sequence but this is a typical way that we change one at a time and then we have both of them these are the 4 different variations or pairs of values that we can have for the two different inputs so OR gate works that any of the input being 1, it will give an output 1, which means you're going to have 1 here, you're going to have 1 here, and both 1 means you're also going to get 1 here. You're going to get a 0 only for this case. That's the truth table for this logic gate. The truth table is basically the characteristic exhibition of the gate's property. It's called truth table. It's a name. I don't know who named this as truth table, but these are called truth table, the functioning tables, which tells us what the logic gates do. To be honest, every logic gate has quite a good number of transistors and diodes aligned with themselves in a very specific way so that they give us this kind of behavior. Now, what is that internal structure and how does this logic gate actually work to give us this kind of output? That is not covered in your syllabus, and I don't want you to bother about that because honestly speaking, I don't know what is inside them. I didn't study it. I don't need it. And then so we just have to understand the part that we are going to have that how they work that's pretty much it the number thing that we have is the AND gate so the AND gate basically is only works both input 1 gives 1 output so AND means it's a combined effect if either of them is not 1 then it will not give 1 so both have to be correct for it to work for example the AND gate shaped like this you have two input lines the input side is a flat line not curved like the OR gate then you have a pretty much rectangular extension just at the end it is a perfectly rounded head have a look at the difference here the sides were curved the head was pointy and the input side was concave here the input side is flat the sides are flat only in the output side it is curved but not pointy smooth curve so let's name them as A B and C A B C might as well paste the truth table so not gonna need this so the way this one works for the truth table is that if we give an input of 0 0 it will give us 0 if we give 1 0 it still gives us 0 because one of the input has been 0 if we give 0 1 it will still give us 0 because another input has been 0 and then we have 1 1 for this exclusive case when both the inputs are 1 it will is going to give us 1 output so that's how the AND gate works you primarily have these 3 gates in your syllabus as your unique gates or what can I say the like the letters of an alphabet and then we're going to see 2 more gates which are going to be a small combination of the NOT gate and the other 2 gates so the fourth gate that we're going to see is NOR gate, and then the fifth is going to be the NAND gate. So the fourth one is, let's say, NOR gate, is NOR. The NOR gate is basically means that you'll do the OR operation first, operation or function, you can use any word. You'll do OR operation first, then reverses it. The circuit symbol for NOR gate is very much similar like an OR gate, but there is a slight difference. Inputs, concave input side, curved body. Now a NOT gate, OR gate would have an output from here. A NOR gate would have a circle over here. This circle basically represents that this is a NOR gate, which means first this is gonna do the NOT OR operation, and then as it is coming out, it's gonna undergo a NOT operation. NOT operation means it's gonna reverse the output. So in this case, if we have A, B, and C, and if I once again paste the truth table, so we have A, B, and C. Thank you. So you have to understand that this is going to be reverse of an OR gate. And now OR gate performance, any of them being 1, you will get 1. So in places where we're supposed to get 1s for an OR gate, we're going to get 0. So OR gate works if any of them is 0, OR gate gives you 0, but NOR gate will give you 1. It will just reverse the OR output. Or in other words, I can say the truth table that we have found over here, we can just reverse it. In place of all the zeros, we can give 1s. And in place of all the 1s, we can give 0s. That's basically how the NOR gate works. So I could write like this, 1 0 0 1 1 1. So all of these things would be 0. So this is just a reversed OR gate, or we call it NOR gate. Although the NOT comes first, I would appreciate if it was OR gate, because that would make better sense, because the NOT is done after the OR. It's not the other way around. I mean, we do the OR operation first, then we reverse it. So that's why it's called an OR gate. So that's basically it. The shape is pretty important for you to remember. And then the fifth one is the NAND gate. Pretty simple stuff. It will do NOT, and then, sorry, it will do AND first. It will do AND operation, and then it will reverse it. So the shape is pretty much simple. First, we have the AND gate. We have a flat input side, flat horizontal sides, circular round output with a circle in the front. The circle in the front represents the NOT operation coming out. So we have A, B, and C. We paste this thing out of here, and we now need the third column. So let's say A, B, and C. We have this, and then I'm gonna fill up this input sides. Now the way AND works is that only for 1 1 it should give us 1. In this case, the NAND, it is gonna give us 0, and AND gate would give us 0 in all of these cases. So NAND gate would simply reverse the zeros. We can use 1 1 1. So that's basically the function of these gate stuffs and everything. Now, one common exercise, just to give a bit of an idea that what kind of questions should we expect, which you're gonna see in the worksheet that I'm gonna discuss after a while. But just to make some acquaintances, where is my federal book? Now, suppose boita koi. আমার বইটা কই? সবুজ বইটা যে পড়াই বলা বান্ধবীকে, তুমি যে বাই করে রাখছো না একটুখানি মাথা? তাহলে মানে আমি আবার সরাই কোনো হানে রাখছি, আল্লাহ আর তো পাওয়া যাবে না। হ্যাঁ, এই কাগজের তালে আছে মনে হয়। এই তো হ্যাঁ, এই আর তো পাওয়া যাবে না। লাইট লাগবে না বাবা, থ্যাংক ইউ। হ্যাঁ, বই পাইছি। My mom is here, so nothing is unfoundable. তোমরা কিছু বুঝছো?
Yes, sir. Yes, sir.
Mom says have the biggest dictionary for house. I mean, you don't find shit to ask them. They're gonna give you exact instruction where to find that thing, and you're gonna find it there. Period. Works every time without fail. It's unbelievable. I think this is how pretty much everyone's going to. What is this page for the logic gates? Can anybody direct me the page number for the logic gate in the federal book? I'll be delighted for your help. বই
জি
কোনখানে বই কোনখানে জানি আছে লজিক গেটের পেজটা আমি খুঁজে পাইতেছি না।
So page number 389.
389 from তাকিয়ে আছে। Yes, beautiful. Hold on, page number 389 টা buy করো। You can see the exact same thing that I went by, except for there is a bit of difference in sequence. So this is the very basic table that I talked about. I didn't want to show it to you manually, but I did because I could and I had time. So that's the basic gate operation that we have. We have not, we have and or NAND and NOR gates, everything. So you don't have to copy this part because you're gonna have this whole thing in your book available. The most fundamental question with this logic gate that we can have is given right below this. There is a self-assessment question that we can see over here. So what is happening in this self-assessment question that we are gonna provide this combination of stuffs, 3 different inputs x, y, and z, and multiple choices and multiple different variation of values 0, 0, 1, 0, 1, 1, 0, and 1, 1. These are given as the x and y input on at 4 different rows on the table. And at different locations, they have labeled 3 possible outputs, A, B, and C. You're asked to fill up this table for the possible logic output. I'm going to do the first one, and I want you kids to attempt the second and third. Take a very good look at the locations where x, y, z are. What are the inputs for G1 between among x, y, z? What are the inputs of G1?
X and Y.
You can see x and y, everyone. ঠিক আছে? তো এখন G1 এর যে শেপটা তোমরা উপরের সাথে মিলায় দেখো, তোমরা এখনই মেমোরাইজ হয়তো নাও হতে পারে, but compare the shape. What type of gate is G1? What gate would you call this?
AND gate.
It's an AND gate, which means only if it will give you 1 only if both the inputs are 1. So for the first row, x and y both are 0. So the G gate will give us an output of 0. So in this place of A, write 0. You can write on your book, but use a pencil so that if you're mistaken, you can erase this. You can write 0 over here. So A position টাতে আমরা 0 পাইলাম। এরপরে দেখো A ইনপুটটা forward জানা যাবে is gonna go through gate 2. Gate 2 represents which gate? A triangle with a 0. It's a NOT gate. So we'll simply reverse that 0. So B will become 1. Make the B 1. ঠিক আছে? You can write this down. And then G3 is gonna come into action. For G3, it has 2 inputs. One is the B and another one is Z. So G3 is gonna function with 2 inputs. One is B, the other one is Z. এখন B টা হচ্ছে আমাদের একটা OR gate. The shape tells us this is an OR gate. So আমাদের B এর ভ্যালুটা কত আসছিল? What is the value for B?
So 1.
1. আর আমরা Z এ ইনপুট দিচ্ছি হচ্ছে 0. এখন OR gate, whenever it is fed 1, 0, it gives us 1 output because if either of the output is 1, inputs are 1, it gives us an output. তার মানে C টা হবে এখানে 1. তাহলে ফার্স্ট রো এর জন্য আমাদের ভ্যালুগুলো আননোনগুলো কি কি হলো? A আননোন, A আউটপুট হলো 0, B হচ্ছে 1, C ও হচ্ছে 1. এটা মিলছে সবার? মানে বুঝে গেছে
Yes, sir.
কিনা যে কিভাবে এটা হইলো? আচ্ছা, I'll give you some time. Attempt the other 3 rows. If some of us do get mismatched, I'll discuss it with you. I'll give you 3 minutes to solve
A0, B1, C1.
A0, B0, C1 for the first row. I want you to try the other 2 rows as well.
Sir, B0.
No. A0, B1, C1. মানে 0, 1, 1. ABC for the first row.
Yes, sir. বুঝেছি।
So বাকি তিনটা row try করো, take 3 minutes at max. Try slowly because this is a sequential process. Sequential process means if you make mistake in one step, that mistake will be cascading down the line. Okay, so it's important that you আমি তো জানতাম PS5 রিলিজ হয়েছে, why PSX is written in front of other moments?
স্যার আমাদের ওই মান্থলি টেস্ট চলছে তো পিএস মানে পার্সিয়াস আমার সেকশনের নাম
আচ্ছা আচ্ছা, sorry.
আমি রিনেম করি নাই
I know. So you don't have to rename. It's okay. As long as I can detect you as the person that I know you by, it's all right. I was just trying to bug you. So yeah, I succeeded, I think. Try করো, পরের তিনটা রো ট্রাই করো, I'll help you.
স্যার
জি বলো।
স্যার আমরা কি রো ওয়াইজ আগাবো স্যার নাকি কলাম ওয়াইজ?
অবশ্যই রো ওয়াইজ আগাবা। এক সেট ইনপুট
Okay.
থেকে হরাইজন্টালি মুভ করতে করতে এক সেট গিয়ে শেষ হবে, তারপর আবার আরেক সেট। I personally like it this way, মানে একটা ফুল কমপ্লিট করার পর আরেকটাতে যাওয়া। To be honest, if you want, you can also go row column wise as well. For example, x5 হচ্ছে একটা AND gate, তাহলে আমি এখানে AND gate আসলে আউটপুটগুলো লিখে ফেললাম। B হচ্ছে একটা NOT gate, তাহলে A সবগুলোকে উল্টা করে এখানে লিখে ফেললাম। এরপর হচ্ছে OR gate, OR gate দেখে দেখে OR gate বসাইলাম। তুমি যদি সেটা করতে চাও করতে পারো, but I like to do it horizontally. But it's your choice. There is no hard and fast rule how you should approach this.
Start down.
আচ্ছা, একটু সময় দিই সবাইকে।
স্যার আমরা done, sir.
You can write up your answers. Can you write up your answers in the table? In the meantime, so these are the values that we got from one of the students, Apotim. So I shared these values. I want every one of you to check your own values and see if you get the similar answers. সবার কি মিলছে? Everyone? দেখো, যদি কোনটা
Yes, sir.
হয় তাহলে আমি এটা ভেঙে আলাদা। So এটা হচ্ছে exclusively মানে gate related question আসলে কিভাবে হতে পারে। But it's really important that you be careful at every step because like I said that one mistake in one point will cascade into further down the scale. So that's what essentially makes a logic circuit, designing a logic circuit very troublesome in some cases. So people who actually first develop them have to be very cautious not to do any miscalculation in their algorithm or not to misplace any of the logic gates in wrong places because then the whole thing would be messed up. So that's basically about the truth table. So we're gonna leave it behind and try solving some question from this paper maybe. So let's have a look one by one. আমি এটা তোমাদের শেয়ার করে দিব। To be honest, এটা আমি এখনই শেয়ার করে দিই। আচ্ছা ক্লাসের পরে শেয়ার করে দিব। I'll keep the recording open and you can see that I have shared it so that you can rest assured that it was actually shared. Don't worry. So first of all, we have this one. Figure 9.1 shows an AC supply connected to a resistor and a diode. State the effect of fitting the diode in the circuit. The diode basically allows the current flow in one direction and stops the current in the reverse direction. So it simply converts the AC supply into a DC output. That's it. So how does this work? So if we have an AC supply over here, we copy this. আমাদের এগুলি তো আর লাগবে না, এগুলো তো বোঝানো শেষ, আমি এগুলো সব ডিলিট করে দিচ্ছি। So if I draw a simple AC supply over here, let's say, you can draw a very basic AC supply as per you can, and drawing at least 2 cycles is always recommended. This diode is going to allow half the cycle to pass through. So in this case, let's say I'm going to allow the top half cycle to pass through. So the output voltage should look exactly similar as the first half cycle, which means you have to match these points precisely. So use ruler. It's better that way, and like that. And this reverse cycle should become flat. No current, no voltage passes this one. So this is perfectly zero. And then the forward bias, this voltage will also pass through. And this lower one will once again become zero. That's basically what the diode does.
Sir, এভাবে অর্ধেক পাওয়ার লস হয় না?
Yeah, yes. a diode will essentially eat up half the power from the supply. So you can never get an efficiency more than 50% using a single diode rectification. This is called rectification. Rectification means converting the AC into DC. But we have double rectification as well, which is going to be shown in one of the later questions, from which you can understand how the actual power cycle is generated from the using the diode. এটা একটু পরে আসবে, আমি ডাবল সাইকেল একটু পরে দেখাবো। এরপর বলছে in the space draw a symbol for a NOT gate, state the reaction of a NOT gate, 1 mark each, sorry 2 mark. Action of a NOT gate বলা মানে হচ্ছে you have to basically mention the truth table for that thing. That's basically it. So first you draw a NOT gate over here. The NOT gate looks like this, the circle, that's it. And then the action of a NOT gate means you can simply write over here input 0 gives output 1, input 1 gives output 0. You could directly write that, or you could write in words that it converts low voltage input into high voltage output, and vice versa. Writing vice versa should work, in my opinion, because it's just the other way around. Still, just to make sure that we are correct, you can have a look at the mark scheme. When input is 1 high or 1, output is low or off. When input is low or off, output is high or on. Okay. They have mentioned both the sentences. Vice versa was not appreciated for some reason, and I don't have the examiner's report over here. That's basically it.
স্যার
Yes.
স্যার টেবিল করে যদি অ্যানসারটা দেই তাহলে কি মার্কস দিবে?
টেবিল করে যদি আনসার দাও, তখন তোমাকে যে কাজটা করা লাগবে, তোমার ওই ড্রয়িং এ আইদার ইনপুট আউটপুটের সিম্বল দেওয়া লাগবে, অথবা তোমার এইখানে তুমি যে ট্রুথ টেবিল তুমি এখানে আঁকবা, ঠিক আছে? ট্রুথ টেবিলের কলাম হেডিং গুলো হবে হচ্ছে ইনপুট আউটপুট 1 0 0 1, then you are going to get perfectly full marks as well. টেবিল করে দিলে মার্কস পাবা।
ওকে স্যার।
মানে either you have to name it input output, or in this figure you can label one of them as A and the one as B, and you can use those things A and B as your input output symbol. That also works. Either ভাষায় লিখতে হবে, অথবা হচ্ছে তোমাকে প্রপার লেবেলিংটা কোন জায়গাতে হওয়ার কথা সেটা তোমাকে দেখাই দিতে হবে।
ইয়েস স্যার।
আচ্ছা, এরপরে কোশ্চেনটা দেখি আমরা। Figure 10.1 shows a circuit based on a transistor and a thermistor. Describe the action of the thermistor in the circuit. Action of the thermistor of the circuit means how does the thermistor will work for the circuit. This is actually a very interesting problem. One of the very basic problems. এই কোশ্চেনটা আমি অনেক ডিটেইলস আলাপ করবো, because এটা প্রপারলি বুঝলে পরের কোশ্চেনগুলো তোমাদের জন্য সলভ করা অনেক ইজিয়ার হবে. So I would like everyone's prime attention on this question. I have to zoom it to 50% to accommodate the whole question. But can everybody read the word letters? Is it readable? Awesome. Let's have a look. Figure 10.1 shows a circuit based on a thermistor and a thermistor. Describe the action of the thermistor in the circuit. আমি প্রথমে তোমাদেরকে পুরো সার্কিটটার ফুল ডিটেইল ওয়ার্কিংটা বুঝাচ্ছি, then you can write the different defined parts that you have to fill up over here. So let me go ahead and explain how this circuit is going to work. Let's say this is a power supply, and just for the sake of easier description, I'm going to label one of them to plus as minus so that I can mark the current. The first thing that I would like all of you to see is that this power supply is having its voltage divided by this pathway. Forget about the internal part for the time being. So let's say I might as well make a diagram with the fill with a solid color. Okay. For the time being,
ট্রানজিস্টরটাতে কি কালেক্টর এমিটার আর বেসটা একটু লেবেল করে দিবেন?
the arrowhead is always the emitter.
Sorry, sir?
The arrowhead is always the emitter. Where we have the arrow, that is always the emitter. So এটা মনে রাখলে easier হয়, because the flat side is base, we know this for a fact. So all that we have to decide between is for the two ends where the main current flows, which one is what. So the arrowhead is always the emitter side, and the other one is the collector side. So এখানে আমরা যে কাজটা করছি, যেটা এখানে arrowhead দেওয়া, so this is supposed to be our primary current flow side, which will be dependent to memory. So for the time being এই পার্টটুকু ভুলে যাও, আমি স্টেপ বাই স্টেপ বুঝাচ্ছি। This power supply will provide the purpose of two things. this power supply is definitely getting divided by the effect of this thermistor and this fixed resistor, which will define how much voltage will be available here. Now, interesting point for you to understand. If the thermistor has a high resistance, then this will eat up most of the voltage of the supply or significant portion of the voltage of the supply. So this one will have a lower voltage value. What do I mean by this? Let's say in a certain scenario, let's say, just to make sense with you, if I'm gonna have to remove this later on. Actually, let me just copy this and then get rid of this. No, I cannot do that. I did make my point that for that, I mean, just forget about that. So let's say this power supply is of 10 volt. If it so happens that this thermistor is currently working at a low temperature, at low temperature, the thermistor have high resistance. So this voltage is going to get divided between these 2 points. So at this point, if this thermistor uses up, let's say 8 volt of the supply, then 2 volt would be available for this one, because this junction is working as a potential divider for this supply valve, which means this one has used up 2 volt, which means currently across these 2 points we have 2 volt remaining, and this lower point basically represents the bottom point of the supply, which means from this junction through this resistor out of this path, মানে এই pathwayতে current flow হওয়ার জন্য আমাদের voltage বাকি আছে only 2 volt. This will give us a very small current flowing through this pathway because the available voltage is only 2 volt, because the thermistor has eaten up most of the voltage. What I wanted to see that current is going to try to flow in this pathway. So এখান থেকে আমাদের current flow হবে এই pathwayটা আমি পরে দেখাচ্ছি. Let's say current is going to come through here. Current is going to come through here. It's going to reach up to this junction, and then the current is going to split into 2 ways. What I'm trying to show you, what fraction of this current is going to flow through this path. The voltage that you're going to have available from here through here, let's say this part over here, is going to be same as the voltage across 2 volt, because you can see that this branch is practically parallel with the R1, which makes that across the base connection or across the R2, we're going to have only 2 volt remaining, which is going to give us some small amount of current. Because now the base current will be quite small, the collector emitter current, this will be also significantly small. This small current will not, I'm using the term solid term not, because that's how you are trying to understand. I mean, you're trying to decide between bright or less bright or glowing or not glowing scenario. When the base current is small, then this pathway current will also be small. So this current will not be good enough or will not be powerful enough to light up this bulb. So in this case, the light will not glow. It will be turned off, remain turned off. So this is happening in which condition? This whole thing is happening when this circuit is operating at cold temperature, or at least the thermistor is operated at a cold temperature. When it is using up most of the voltage from the supply, so a very small fraction of the voltage is available for the base current part. Very small current is flowing to the base current, which is not allowing a significant current to pass through the emitter collector connection, so the bulb will not glow. Now, I have to make sense with you, I have used 8 and 2 volt, but this can be even severe to that. This all depends that what is the ratio of these two resistors are. R1 is a fixed resistor that we can choose and place as per our wish, whereas the resistor of the thermistor will depend upon the temperature of the environment within which it is performing. So it can also be that, I mean, if this is working at a very low temperature, this could as well eat up 9.99 volt of the supply, and maybe only 0.01 volt is available over here. The point I'm trying to make is that depending upon the resistor differences of these two things, the sharing of the voltage can be extreme. So bottom line, if this circuit is working at cold temperature, this light bulb will not glow. Then let's say we're starting to increase the temperature of the, we're starting to increase the temperature of the environment. And if we start to increase the temperature of the environment, which I'm going to write now with red, let's say, in that case, this one's resistance will slowly decrease and this one will remain fixed. But since this one's resistance is decreasing, so their sharing would be different. So let's say after a certain point, let's say this is now, no.
Is it possible for the thermistor consumption to be 10 volts?
However,
Sir, given that the temperature is low enough, can the thermistor take in all the 10 volts?
practically no, because the way the way the formula for the variable resistor works, potential level works, that V1 equals to R1 divided by R1 plus R2, ঠিক আছে, into the supply voltage. This is the basic formula for one of the voltage across one of them. Now R1 or maybe this one can never be zero. This fraction can be very close to 1, but this will never be 1, because no matter what small value of R2 you give, it will the denominator will be always somewhat bigger compared to the numerator, right? Even if this is 1000 and this is 1, you have 1000 by 1001, which is a proper fraction. So
Yes.
mathematically speaking, the thermistor can never take the full voltage for the power supply. For practical purposes, we can say that if it is really close to 10 volt, we might as well declare that as 10 volt. That can work. But mathematically, no. বুঝা গেছে?
Yes, বুঝেছি।
আচ্ছা।
স্যার এই পোটেনশিয়াল ডিভাইডার ইকুয়েশনটা কি যে কোনো সার্কিটে ইউজ করা যায়?
If it is applicable for the circuit design, in this case it was applicable for the circuit design, that's why I could use it. যে কোনো সার্কিটে ইউজ করা যায়, but you have to understand the applicability of the circuit of that equation for that given scenario.
Sir, potential dividers divide up the entire power supply. Yes, sir, but যে অংশটা divide করে, isn't it getting wasted?
What do you mean by waste?
মানে যে in this power supply of 10 volts, it is being broken up to 8 volts and 2 volts. 8 volts are being wasted, right?
Not essentially. Having a voltage across a certain component doesn't necessarily mean that voltage is wasted, because you have to understand that voltage cannot be wasted. You can actually waste energy. If you do not use your energy for a practical purpose or a purpose that you want to work, I mean, if some energy flows out of your system in a way that you do not want it to flow out, that's basically what we define as a waste. The reason I would not call it a waste, because the thermistor is currently having a voltage difference of 8 volt, and maybe an R1 for my example was having a voltage of 2 volt. This is giving this point a special characteristic, which is controlling my current through the base current. That enables me, or that helps me to automate the switching on and off of this bulb. At the cold temperature, this bulb is not working. It is remaining off. But whenever, so it is actually serving a purpose for me. I'm not using the current that is going to flow through this pathway to light up the bulb, but without having some current flowing through this electrical circuit part, I cannot have this bulb getting automated, or for this bulb to work automatically with temperature variation. I'm trying to use this circuit that should be able to sense the temperature of the environment by introducing a thermistor. So because of the thermistor, this thing should be able to turn the light on and off for two different temperature range, let's say low temperature and high temperature, to achieve that variability of its performance. That in one temperature you're going to have one state of light, in another temperature you have another state of light. You need to have some voltage applied through this part of the circuit. So it's not essentially wasted, but that part of energy is not used to light up the bulb. But without having this thing working, you cannot make this whole thing automated. Does that make sense?
So the energy is being used indirectly, not directly.
Exactly.
Sir,
So
indirectly use করতে বলতে ওই জিনিসটা বুঝি নাই।
indirectly means to how much current should flow through this pathway is depending upon how much current flows through this pathway. That's a dependent factor. That's how the transistor works. Now we are controlling how much current flow is going to happen through this path by the introduction of these two resistors over here. So a small amount of current will definitely flow through this path. I mean, you're gonna definitely have some current flow through this path. This current flow path is not actually helping you to light up the bulb. This is supposed to work as our warning or as our signal or as uh, some sort of sensing output device, which actually tells us what is the state of temperature over here. So this current that is going to flow through this part of the circuit or through this part of the circuit is not essentially passing through the bulb. Although it's not very significant in terms of proportion, maybe 1% or maybe 0.1%, but it is not used up to glow your bulb. But you're using this current flow to make sure to control the behavior of the bulb as for how it's going to operate. So without having this thing functioning, you cannot have this bulb working the way you want. So that's why I'm saying that it is being indirectly wasted. Indirectly wasted. Actually, I'm not going to say it's wasted at all, because we want that voltage variation on the left side of the circuit to exist for that bulb to operate the way we want it to operate. So it's not essentially wasted, but it's not essentially wasted, but it is not definitely used to light up the glow of the light bulb. So it's another type of supply. If I give a
অন্য একটা বাল্ব কি জ্বালানো যায়, ধরেন যতটুকু ওয়েস্ট হচ্ছে তো ওইটার জায়গায় অন্য একটা বাল্ব জ্বালাইলাম যেটা দিয়ে হচ্ছে ইন্ডিকেট করবে যে লো টেম্পারেচার।
Well, if we use a different light bulb, that light bulb would be experiencing a very small fraction of voltage. So that light bulb have to be designed to work under a very small voltage with the supply of very small current. So the power of that light bulb would also be very low, which means that information will be practically non-useful for you. If a light bulb that is glowing within the circuit that is not even bright enough for you to see it, what difference does it make? Okay,
স্যার
so that's why we would appreciate the signal bulb or the thing that will give us the information to be connected in the emitter collector branch, so that whenever this is supposed to glow, it can take a huge current flow from the power supply and make a pretty light, bright glow that can give us the information. Yes.
স্যার ওই R2 থেকে যে কারেন্টটা বের হয় আর বাল্ব থেকে যে কারেন্টটা বের হয় দুটো কি সেম থাকে?
না, দুটো সেম থাকে না। R2 কারেন্টটা অনেক ছোট হয় আর বাল্বের কারেন্টটা টিপিক্যালি অনেক বড় হয়। There is usually a fixed fraction between them, which can be designed within the transistor by controlling the thickness of the PNP sandwich parts.
স্যার তাহলে টেম্পারেচার যখন বেশি মানে বেশি কোল্ড থাকে তখন তাহলে লাইট আপ করে না, কারণ ছোট কারেন্টই তো যাচ্ছে।
হ্যাঁ, এখান থেকে ছোট কারেন্ট যাচ্ছে, বাট মনে করো হচ্ছে এই লাইট বাল্বটা একটা ফিলামেন্ট বাল্ব। How does a filament bulb work? Think about it. For a filament bulb to work, you have to have enough current flowing through the filament so that it will heat up the filament, and that heat energy will ultimately convert into light energy. ঠিক না? এখন মনে করো এই ফিলামেন্ট বাল্বটা রেটেড করা আছে হচ্ছে, লেটস সে এই ফিলামেন্ট বাল্ব রেটেড করা আছে মনে করো হচ্ছে for I mean for the power of any electrical component is given by P equals to I square R. So if you want to have significant power output from this device, you need to have a significant value of I. If the I flowing through this branch is actually quite small, like really small. Why small? Because the base current is also very small. If the base current is very small, then the collector emitter current will also be very small. So I might as well label them base current, this is collector, this is emitter. So if the base current is small, then the collector emitter current will also be very small. That small current would not be significant enough to be able to light up this bulb. Let me give a very simple example. Let's say if we buy up a regular bulb from the shop, filament bulb, and try to connect it with a 1.5 volt battery, would it light up? Normally speaking. Did you get my point? আমরা যে নরমাল আমাদের এসি সাপ্লাই বাসায় যে এনার্জি বাল্বগুলো লাগাই, লেটস সে ওগুলো ইকুইভ্যালেন্ট ফিলামেন্ট ল্যাম্প বাল্ব তো পাওয়া যায়। বুঝছো কোনগুলো কথা বলতেছি?
জি স্যার, ইয়েলো কালার।
হ্যাঁ, যেগুলো ইয়েলো কালারের, যেগুলোতে অ্যাকচুয়াল একটা ওয়্যার থাকে। So let's say you buy one of those bulbs and take a 1.5 volt battery, or maybe two of those batteries of this supply, and then you connect them with the circuit. You would not find that the bulb is glowing. But if you ask that, are you not feeding the bulb energy? The answer is yes, we are feeding the bulb enough energy. But that energy is not good enough to light up the bulb. We are having current flow through the circuit. Yes, the batteries are draining, but that rate amount of power supply is simply not good enough to make the filament start glowing. So whatever the heat energy that we are producing in that filament bulb is getting dissipated from towards from the atmosphere before the temperature could rise to such a value that it can become glowing hot. So to make sure that the bulb glows, you need a minimum amount of current flow or energy supply through that equipment that will actually make it function. বুঝতে পারছি?
জি স্যার।
স্যার সো দ্যাট স্মল অ্যামাউন্ট অফ মানে একটা ফিক্স অ্যামাউন্ট প্রো করতে হবে লাইক
Minimum. I would use
হ্যাঁ
from
মিনিমাম
minimum. I would
বেজে
use from minimum.
বেজে কারেন্ট স্মল হবে বাট বেশি স্মল না।
না, basic current অনেক small হবে. It might be within the range of, let's say, milliampere or microampere, milliampere, or maybe 100th of an ampere scale, or you can get maybe 1 ampere through here. So that depends upon the design of the transistor. But the base current will be very small compared to the collector emitter current, like very small, like
ইয়েস স্যার
stupidly
ইয়েস
small.
স্যার বুঝছি বুঝছি।
স্যার তাহলে ট্রানজিস্টরের রেজিস্ট্যান্সের উপর ডিপেন্ড করে আর কি বাল্বের কারেন্ট ফ্লো থ্রু হয়।
ট্রানজিস্টরের প্রপার্টির উপর ডিপেন্ড করে, এটা একটা ফ্যাক্টর। আর একটা হচ্ছে যে ফিজিক্যালি আমরা বেস কারেন্টটাকে কতটুকু অ্যালাউ করতেছি, সেটা হচ্ছে আমাদের মানে মানে সার্কিট ডিপেন্ডেন্ট ফ্যাক্টর। ট্রানজিস্টর প্রপার্টিটা হচ্ছে আমাদের ম্যানুফ্যাকচারিং ফ্যাক্টর। সো ইউ ক্যান বাই ডিফারেন্ট magnification value of transistor. For example, if you have a transistor of, let's say, with a magnification factor of 100, this would mean that each ampere of current in the base would allow up to 100 ampere of current in your collector emitter branch. আর কথা হচ্ছে 1 ampere দিলে 100 ampere সে অ্যালাউ করবে, বাট 100 ampere সে ফ্লো করবে কিনা সেটা আবার এনশিওর করার জন্য তোমার ওই লেভেলের পাওয়ারফুল পাওয়ার সাপ্লাই থাকতে হবে। আমি এখানে 1 ampere কারেন্ট ফ্লো করলাম মানে এখানে আসমান থেকে 100 ampere চলে আসবে না। Allowing 1 ampere through here, if you have a magnification factor of 100 for the transistor, allowing 1 ampere through here can allow up to 100 ampere through this branch. But that does not mean 100 ampere will by default generate within the transistor. No, you have to have the means and path to make 100 ampere flow through. And then if you allow 1 ampere through here, then the 100 ampere can pass through. Or if you allow, let's say, half ampere through here, 50 ampere can pass through. Or if you apply 0.1 ampere through here, 10 ampere can pass through. It's going to maintain that ratio of 1:100 to maximum. But to make happen that current flow through this branch, you need to make sure that the required voltage supply is connected to make sure that current flow exists. বুঝতে পারছি?
Yes, sir.
আচ্ছা, it's good that you guys are asking questions, because that's how we can actually get out of the confusions. I really appreciate that. So keep shooting questions if I have any. I appreciate this. So I'll go to the next part of the discussion, which is going to be just the reverse part. Reverse means that now if we start to operate this whole circuit, especially let's say the thermistor, in a hot environment, when the temperature of the thermistor becomes high, its resistance gets low. So it starts to lose resistance. So in a hot environment, this will have a smaller resistance, this will have a bigger resistance, which essentially means that this will have a smaller voltage consumption, this will have a larger voltage consumption. So if I now do that one, let's say I'm going to write this with red. Let's say in a hot environment, this one, let's say, uses 1 volt. I'm just using different values so that you don't confuse between 8 and 2. And let's say this one is 9 volt. So having a 9 volt voltage across these 2 points will allow 9 volt across these 2 points as well. And we have kept this R2 resistance over here. The purpose of this R2 resistance is that so that the IB current does not become too large, because a very small IB current enables this circuit to work. So we don't want this base current to become extremely large. So even when there is a very high amount of voltage available, the purpose of this R2 resistance is to limit or make sure that the base current is kept within acceptable range, so that
Sir,
you do
what
not
happens if
flow.
it is
Just a second, একটু শেষ করি, so that we do not flow an infinite amount of current through this branch that might as well burst or melt the filament of our bulb or make the bulb dysfunctional. We don't want that to happen. So we want to have this R2 resistance over here, so that even when there is a large voltage available across the base connection point, the IB current can be limited to a maximum value. So that's the purpose of the R2 resistor. So when this is happening, this is 1 volt, this is 9 volt. A significantly larger current will flow through this branch current compared to when it was 8 volt and 2 volt, and that will open up the collector emitter branch for a very significantly large current to flow through this path, and that will make the bulb glow. Which means, একটু শেষ করি তারপর আমি কোশ্চেন দিচ্ছি, give me 3 or 4 minutes time, just remember your question, just give me a bit of time. Which means this circuit can work to sense the temperature of the environment by the functioning of this thermistor. This is the important bit that I want you to take in. The way this thermistor is working, I'm going to write this up over here, is that in some sort of cold environment, it is not going to glow, no glow, and in hot environment, it is going to glow. So that's the purpose of this thing. Now, let's say we want to fix it. I'm going through the different variation or iteration of this thing. Let's say we want to reverse this factor. Reverse this factor means, let's say we want to operate this bulb in a way, we want to operate this circuit in a way so that is gonna become, it's gonna glow in the cold environment, it's gonna not glow in the hot environment. So how can we do that? Simply we have to change the IB current. So all that we need to do, connect this thing over in this place and connect this thing over in that place. If you flip the position of these two voltage dividers, then your voltage sharing would become simply reversed. So you are simply going to get the opposite factor. So placing the thermistor over at the bottom is going to make at cold environment glow and at hot environment not glow. I'm practically use glowing here to পড়া লাভ করতেছি, but এই রিভার্সালটা বুঝা গেছে কিনা? If you switch up the position of these two resistors, you're going to have the circuit working just the opposite way, so that your circuit is going to behave the opposite way. এটা হচ্ছে একটা অ্যাসপেক্ট। সেকেন্ড অ্যাসপেক্ট হচ্ছে,
স্যার আমি এই পার্টটা বুঝতে পারলাম না। কিভাবে?
if we swap out these two components, then in cold environment it's going to be 8 volt and 2 volt, which means there would be 8 volt available through here. So large current can pass through the IB branch. It will glow.
জি স্যার, জি স্যার।
বুঝছো এখন?
Yes sir.
Sure, no problem. এটা হচ্ছে একটা aspect that we can use it to do both of them depending upon what we want to do. যেমন আমি একটা practical example বলতেছি, মনে করো if you want to use this device within let's say within a cold storage device. Now cold storage rooms are large amount of storage devices where the temperature is kept low to store typically food stuffs to be sold later on. So you want to make sure that the temperature of a cold storage does not rise up above a certain value. Let's say the highest temperature that you can allow for the cold storage is, let's say, 4 degrees Celsius. Let's say your preferable temperature should be below that. Now the thing is, if you really want really strong cooling mechanisms and refrigerant mechanisms, the more refrigerant unit you're gonna run, the more electricity bill you have to pay, which is gonna cut off from your profit. So you want to run the minimum number of refrigerating units which can functionally keep the temperature below 4 degrees Celsius. So you don't want to install a lot of them, because installing a lot of them will definitely make it more cooler, which goes without saying. But you don't want, that's not economically sound idea. So you want to install that many cooling units so the temperature is kept below 4, and you don't want to make it up to reach to 0, because that will freeze up all the food and it will actually destroy the texture of the vegetables and everything, tomatoes or whatever. So you don't want to freeze them. So you want to keep it liquid, but within, let's say, from 0 to 4. So you want to set up a certain warning mechanism within the cold storage device, where at least this thermistor part should be placed within the cold storage. If the temperature goes above 4 degree, then some sort of light should glow up in some warning location, let's say in the office of room of that cold storage, that would let them know that the temperature is rising, so you better check out your refrigeration system. So in this case, we want a warning for if we want to use this device for a cold storage, we would want a warning when the temperature is hot above a certain value. 4 degrees Celsius is still a pretty cold temperature for our regular experience, but here the important bit is that the temperature should not become more than 40 degrees Celsius. So which means in this case, we want the light to glowing up, or in the place of this light bulb, we can also have a loudspeaker connected, which can also give us a siren, or you might have both of them connected in series so that both of them can work, or we might have both of them connected in parallel so that we have equal voltage supply for both of them. So there'll be an audio signal from the loudspeaker, there'll be a visible signal from the light bulb, so you can have both of them working simultaneously. But interesting enough is that we want this device for a cold storage to give us a signal when the temperature is high. So for a certain hot condition, this needs to glow. For a cold condition, this does not need to glow, which means this orientation that is printed over here is good for us. Although we have to make sure that you can see that this is actually circuit. All of these parts are connecting wires. So it means that by extending this connecting wires, you can place all of these equipment in different places. So all that you have to do, increase the part of this part of the wire and increase the length of this part of the wire and place the thermistor inside the cold storage. And you can take and you can give the power supply from any part of your supply connection, and you just have to bring these two things into locations where it is visible for you or your employees or for your management people to see it. So that's how you can design the circuit in different places so that it is functional for you. This is just one of the examples that I'm putting. Another example that I can tell you is that, let's say in another environment, you want to uh, bake stuffs. Bake stuffs means, let's say it might be a food baker. Let's say you are trying to make some clay ceramics. You have a ceramic factory where you have to eventually heat them all up and bake the whole thing so that the whole surface becomes finished and smooth. So ceramic clay pots have to be baked at a pretty high temperature for the vitreousing effect. I forgot the actual name, but you have to bake them. Bake them means you have to keep them at a high temperature for a prolonged period of time, which does some significant chemical reaction, which rearranges the molecular structure, which practically gives us that smooth finish of clay or ceramic or porcelain utensils. Now, to achieve the best output reaction output or surface finish for your personal preferred combination of clay, you might require a very specific temperature. Let's say your highest possible temperature cannot reach more than 150 degrees Celsius. It's actually far higher, but I'm just saying 150 degrees Celsius. So you want to set up a sensing mechanism within your baking chamber, that if the temperature somehow is going above 150 degrees Celsius, this should allow to give us some sort of signal. So in that case, it should give you a certain signal if it becomes too hot, and it should not give you any signal if it becomes too cold. Sorry, I'm ulta bole say. Your temperature cannot go below a certain value. For that is the more important factor for the baking. So in the case of baking for ceramics, your preferred temperature should not go below a certain value, because below a certain temperature, that chemical reaction would not occur. So if you want your device to work at a temperature, if you want to achieve some signal that should not that should warn you about a low temperature, then you can simply swap out these two pieces, and you can have it as a detector for lower temperature. Lower temperature means a lower threshold of temperature. So if the temperature goes below that value, that is gonna light up this bulb. Now you might wonder, how on earth are we going to use the same device for two different cases? That choice actually depends upon the choice of this resistor, because you have to understand, it is this resistor that will share voltage with this one from the power supply. So if you want to make this whole device work for a 4 degrees Celsius temperature variation, you need to choose a certain resistance over here, which is going to give you a comparable value of the resistor of the thermistor resistor at 4 degrees Celsius. So that will give you one choice of the resistance. If you want this thing to perform it at a hot temperature, then you'd have to choose a different resistor over here. So by controlling the value of this resistance, we can actually fine tune this whole circuit, that exactly at what temperature this bulb is going to light up. So different resistance values over here will essentially control the different voltage remaining for this lower part of the circuit, which can control exactly at what value the current IB value goes high enough so that the light actually starts to glow. So you can essentially control the temperature sensitivity of this thermistor or of this entire sensing circuit by controlling the resistance of this. So in many cases, maybe in the lower cases, we will see that we can have a variable resistor placed in place of R1. A variable resistor placed in the place of R1. It means that that will allow this one single sensing mechanism to be used in a lot of different parts of the world, or for a lot of different purposes. For example, let's say I want to run a cold storage where I want the signal for 4 degrees Celsius, and the scientist who is doing some laboratory work want a signal in their science chamber where the temperature should not go more than minus 25 degrees Celsius. So it should be always below minus 25. So they can fine tune this resistor value so that this whole thing can work at minus 25. So it will not give you a signal if the temperature is below minus 25. Whenever it go up, it will give a signal. So you can fine tune the performance of this whole thing by controlling the resistance of this thing, so that you can essentially fix up the exact temperature for which this will work. So this is another aspect. So I have talked about a couple of things. First of all, we can use the same device for both type of warning, too hot or too cold, by swapping out these two pieces. The second thing that I have told you is that we can fine tune exactly at which temperature this will blow up by controlling this resistance value over here, so that we can have the sharing measured and activated through the base current for a very specific temperature range or for a specific temperature value. The third aspect is that this same device can be made into a light sensing device or brightness or darkness sensing device if you simply replace this thermistor with an LDR. LDR symbol হচ্ছে এরকম, two arrows coming in, because an LDR is a sensing device which can sense the light intensity. So if you replace this thermistor with an LDR, this entire circuit will become a light sensing device. So at high brightness, it will work as if with a low resistance, something similar to if this thermistor was working at high temperature, because at high temperature, the thermistor has low resistance, and LDR at high brightness of light, it has low resistance. So similarly, and vice versa. So by choosing the specific type of input component in this place, we can either make this circuit to work as a temperature sensing device, or we can make this device into a light sensing device. So that can also work. So that's the part that I wanted to conclude up till this now, and then I'll take questions from you. Anyone? বুঝা গেছে কিনা?
স্যার R2 না থাকলে কি হইতো?
If R2 was not there, what is possible that whenever the voltage through this branch would be pretty significantly high, if R2 did not exist, this is a perfectly straight line, IB can become significantly large as well, which means in this case, IB would drain, because this pathway would be open. Your bulb is gonna glow and it's gonna pull its own current. Let's say currently it is pulling 2 ampere, and let's say the way this transistor is designed, that to make sure that the bulb operates at 2 ampere, you need to have, let's say, 0.02 ampere as IB. So this much current in IB enables this pathway to be open, which means if this has to be achieved for this scenario, the total drain current from your power supply should be 2.02 ampere. 2 ampere runs the bulb, 0.02 ampere runs the base current, and your whole circuit works. If R2 did not exist and there was a high voltage available here, maybe this IB would have the capability, or it would have the ability, because the resistance is not here, for itself to become, let's say, 1.5 ampere. If 0.02 ampere opens it for 2 ampere, 1.5 ampere will also open it for at least 2 ampere. Actually, this bulb path would be opened for a much higher value of current, which should not be much of a big trouble, because typically the voltage rating of this bulb and the power supply are placed in very close vicinity. So this bulb has pretty much the same voltage rating as the power supply. So which means the bulb cannot get more than 2 ampere at any case. But because if the resistor is not here, this IB branch would simply pull another 1.5 ampere, which means in this pathway, you're gonna have 1.5 ampere coming through. Actually more than 1.5 ampere, because this current has to go through here. One thing part has to flow through here, and the other part should flow through here. So maybe it should be more than 1.5 ampere. So let's say it is 1.6 ampere. I'm just assuming these numbers. and 2 ampere will flow through here, which means your power supply in that case would have to drain 3.6 ampere. And you can see that out of this 3.6 ampere, only 2 ampere is being your practical use output, which is glowing the bulb, and this 1.5 ampere for this large current was actually not needed. So that's a bit of wasted energy because we don't need that much. We need some, but we don't need that much. And another important reason is that transistor is an electronic component, and we have made this component work by altering the property of the semiconductor piece at atomic level. They have a certain capability for maximum current handling capability. যেটা আমি তোমাদের লাস্ট ক্লাসে দেখালাম যে 5 ohm resistor can be of different sizes depending upon the power rating. Transistors are typically not designed to handle that kind of large amount of current. They are designed to operate at a very small amount of current for most part. So and this CE connection can actually handle a large amount of current because this part is supposed to handle a large amount of current, but the BE part is not designed to handle that amount of current, because if you remember from the last figure, from the last class, if you remember, there was a situation that we had the sandwich over here. This was the N, this was the P, and this was the N. The base current was entering through here. So this is the amount of interface that we have to allow the base current to enter or the electrons to pass out. If you actually want to flow, let's say 1.5 ampere of current through this small amount of orifice, essentially you're going to make a pretty high resistance, because that simple ratio, that resistance is inversely proportional to cross-sectional area, works everywhere. A small cross-sectional area will give you a high resistance. So practically speaking, there is a pretty significant resistance, and if you want to flow a pretty large amount of current, you're going to end up with a pretty high amount of heating on this interface, which is not going to be a very good thing for your transistor component. I think that makes sense.
Yes, sir.
Beautiful. Any other questions so far?
স্যার আমি আসলে স্যার R1 এর ফাংশনটা বুঝতে পারতেছি না।
Try to visualize the circuit without the presence of R1. Let me paste a fresh copy of this so that it might be easier for you.
স্যার
হ্যাঁ বলো আশাবুল।
স্যার ওই যে ওই এন আর পিটা ওটা আবার একটু বুঝাতে পারবেন? একটা আমি বুঝিনি।
এটা তো লাস্ট ক্লাসে ডিটেইলসে বুঝাইলাম।
স্যার ওই ক্লাসে আমার নেট ডিসকানেক্টেড হয়ে গেছিল ওই সময়।
আচ্ছা ঠিক আছে, শোনো
করতে পারিনি।
ওকে, সমস্যা নেই, ডোন্ট ওয়ারি। আমি ডেট মানে সিকোয়েন্সিয়ালি লেকচারগুলো আজকে ক্লাস পর আপলোড করে দিব। তুমি লাস্টে একটু দেখো, দেখে যদি না বুঝো আমাকে নক করো, আইল হেল্প ইউ পার্সোনালি, ঠিক আছে?
ওকে স্যার।
আচ্ছা ঠিক আছে। সো এখানকার আইডিয়াটা হচ্ছে, তাকে যে কোশ্চেনটা করছে যে R1 এর পারপাসটা বুঝতেছ না। Try to have a look at this circuit without the presence of R1. If R1 did not exist at all, let's say R1 doesn't exist, there's a single state path line of current. So what is happening? This power supply is providing this current flow, and this resistor will take the entire voltage of the power supply, because you have to understand, if this is a 10 volt supply, let's say this is a 10 volt supply, this is the plus and this is the minus end. And if I want to, just for the sake of easier understanding, let's say I'm going to connect this part to ground. I'm connecting this part to ground to make sure that this whole wire, which I'm labeling with blue, is, let's say, 0 volt. And all of this wire, which I'm labeling with, let's say, brown, which is connected with the positive end of the battery, this entire part of the wire is operating at plus 10 volt, because the supply is 10 volts, which means that difference of the two sides should be 10 volts. Just to make easier sense, this would mean what? If this resistance doesn't exist, the entire 10 volt would be available across the thermistor, ঠিক না? Here we have 0 volt,
Yes sir.
here we have 10 volt. So it will have some current flow. So what would be the voltage of this point? 0 volt, right?
Okay sir.
What is the voltage of this point? This connected to the negative side of the battery. Have a look. This is the blue line. 8 point of 0 volt হওয়ার কথা না?
Yes sir.
So if you have both the sides of the base current to be 0 volt, would you ever have any current in this branch? No.
Sir, বেজে স্যার সবসময় একটু হইলো স্যার কারেন্ট থাকতে হবে স্যার কালেক্টর থেকে এমিটারে যাওয়ার জন্য।
Exactly. A very
Okay,
small
sir.
amount of current will allow a large amount of current through the collector emitter branch, but you need to have some current in the base current for that to be opened. Zero base current will allow you zero current to the other branch. Even a small amount of current in the base current will open up the collector emitter branch by a lot, but you need to have some current allowed. To make sure that current is available here, we need to have this resistor over here so that this point's voltage is not 0 volt. Now, if we have this resistor, if you consider the presence of this resistor, all right, now you're going to have a sharing of the voltage. Maybe this is 9 volt and this is 1 volt. So now the voltage of this point is plus 1 volt. This lower end is 0 volt. This end is at 9 plus 1 volt and this end is plus 10 volt. Which means there is a voltage difference across these 2 points. You can have some current flow through this branch. That might as well allow the other thing and the circuit might as well work. Sure.
Yes, sir. বুঝতে পারছি। Thank you, sir. Just.
Sure, no problem. So that was the discussion that I was trying to get at. So I'm not gonna. Well, let's now look at the question for that. What the question have for us. Describe the action of the thermistor in the circuit. Okay, I just described how this works as it works as a potential divider. Still, we might as well look at the exam mark scheme. So, so what they have to tell us. It says when temperature rises, resistance falls, or vice versa. It means you can write the other information and still score this mark. PD across it falls or equivalent, which means that if you say resistance falls, you have to say PD falls. But if you say when temperature increases, resistance increases, PD across it increases, you're still gonna get mark. So whatever you write over here should be in line with whatever you mention over here. These two sentences should be corresponding to each other. That's why they have given or vice versa to both of them. So you get 2 marks over here. This is the basic purpose how it works. Idea of causes transistor to switch on lamp or lamp off. Here, this thing, I mean, you cannot simply write idea of this. You have to express this idea in your own words. So how am I going to write this answer? I might write it in this way, that I'm going to answer this question for one set of scenario, and at the end I'm going to write vice versa, so that I don't have to do much work. So this is what I'm going to choose. I'm going to say when temperature is cold, the resistance of thermistor is high. The voltage shared from the power supply is also high. So voltage across R2 is low. IB is low. I can write in words, base current is low. So collector emitter current is not significant and bulb does not blow up. And vice versa. The last vice versa means if you change up everything, then everything would be reversed. I'll say it again, and I want all of you to follow through. And if you have confusion at any point, I want you to stop me and ask me questions. Have a look. When temperature is low, the thermistor resistance is high, comma, voltage of thermistor is high, comma, voltage across R2 is low, or you can write small, comma, base current is small, comma, collector emitter current is also small, comma, bulb does not blow up, or you can write bulb does not switch on, full stop, and vice versa, full stop. বুঝা গেছে কিনা?
স্যার
বলো।
স্যার বাল্ব তো গ্লো করে না স্যার, কারণ কারেন্ট কম থাকে স্যার, ভোল্টেজ তো এনাফ থাকে স্যার বাল্ব গ্লো করার জন্য।
Yes, but the power equation was given P equals to I square R. If you don't have enough power, your filament lamp might as well heat up, but it does not heat up to the point where it starts to glow.
ওকে স্যার।
If you think about, let's say, what if we don't use a filament bulb? If you use another type of bulb as well, every device has a rated voltage and power. For example, let's say a normal fluorescent lamp. It has rated voltage of 220 volts, 60 watts, which means whenever you are going to provide 220 volt AC across it, it is going to give you a, it is going to consume a power of 60 watt from the supply line. The light will be something less because it will always have some heat associated. So now, if you provide it 220 volt from a supply which is only capable to give you 1 microampere current, this bulb is not going to glow up because it cannot manage using 1 microampere current to consume a total of 60 watt power. You have to allow it to 20 volt and also have enough current flow in the supply so that it can consume 60 watt from the supply. Only then can it give you the glow. So you have to make sure both of them are available.
Yes, sir. So, sir, we use a bulb that takes up a lot of power.
We use a bulb that takes a certain amount of power, which we will choose depending upon what temperature do we function it for. So the choice of this bulb is also pretty important for that. How much current does it have to flow for it to actually function?
Okay, sir.
বলবান আমার ডিসক্রিপশনটা কি বুঝা গেছে সবার?
Yes, sir.
Anyone? There are still 26 people in this case. I'm getting exceptions from 2 or 3 people. বাকিদের বুঝা গেছে কিনা?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
দেখো বুঝা না গেলে কোশ্চেন করো, I'll help you. আচ্ছা, এরপরে কোশ্চেনটা বলছে state and explain how the circuit may be modified so the lamp switches on at a different temperature. So এটা basically preferable answer হবে we change the value of the resistance R1. State and explain. Acha, which will change the voltage across R2, which is responsible to provide a significant base current to turn up the light bulb on. So I'll say it again. This is how I'm going to write, but I might be wrong. So I'll have to look up in the mark scheme to find what they have to say about this. We change the value of resistance R1, which changes the voltage across R2 to make a significant change of the base current, which causes the light bulb to glow up at a different temperature. So, yep.
Sir, could you repeat one last time?
Change value of R1 or use variable resistance or swap R1 with something. Brief explanation in terms of potential divider. So this type of masking actually is a bit difficult because actually this leaves the choice on the examiner that what they should expect from you. So the idea of potential divider is to be used because I was saying that changing the resistance of R1 actually changes the voltage across the R2, which changes the base current, and that essentially causes the collectometer current to be changed and the lamp to blow up at a different temperature. So basically the change of R1 causes the whole thing to happen, which I just described in the original discussion. There is a state 1 practical use for this circuit. So this circuit is over here. So whenever it's cold, this bulb will not glow. As the temperature goes higher, beyond a certain temperature, this bulb will glow up, which means this can work as a signal for a high temperature threshold. Means from the cold, if the temperature is rising, the lamp will glow up at a certain high temperature. But if the temperature keeps on going down from a given value, the bulb is not going to glow up for any given lower value of temperature. It's going to glow up at a certain higher value of temperature. So it can be used to detect temperature rise. So in places where temperature rise is not expected or is something that you want to be warned about, you can use this. So you can use it in cold storages, you can use it in ovens, let's say in industrial ovens where you have to bake stuffs at a fixed temperature. For example, let's say you have figured out that to make the most tasty buns, the baking temperature has to be about 70 degrees Celsius. You don't want it to be 72, you don't want it to be 68, you want it to be 70. That's your recipe. So you can set it up there as well. So if the temperature goes higher than that, so it can be used in all the places where a high temperature needs to be detected. So it goes there: fire alarm, refrigerator fail light, other automatic lighting systems. Yeah, refrigerator fail light means what? If your refrigerator fails, then your temperature of the inside the refrigerator will slowly go up. As it goes up beyond a certain high temperature, you'll have a warning lamp comes up telling you that the temperature is rising. Take care of your system or your foods are gonna go waste. আচ্ছা সাবির একবার বলতে বলছিলা I said it again without responding to you, but did you catch it?
Yes, sir, I did.
Beautiful.
এটা কি অপশনাল থাকে নাকি
কি
ইলেকট্রনিক্স এর কোশ্চেন কি অপশনাল থাকে না?
হ্যাঁ সবসময়। So question number 9 says figure 9.1 shows an AC supply connected to a series to a diode and a resistor. So we have this thing. They are asking us on the axis figure 9.1 diode graph in the variation of the current in the resistor. So you just have to draw that shape that I showed you earlier. Half the cycle is missing. Now comes this interesting behavior, which I'm going to talk about. This is a pretty interesting thing. This is called what you call a. This is actually not a part of the syllabus, but since it is available, I might as well discuss this to you. Figure 9.2 shows 4 attempts A, B, C, and D to connect a circuit known as a bridge rectifier. The circuit is connected to a 12-volt AC supply. There are 4 options. Looks like an MCQ question, but trust me, it's not. Oh, it is. In which circuit will the direction of the conventional current in the resistor always be from red to black? Beautiful question. So we have to do some work for it. Let's give it a try. Why can I not select this? Select.
Sir, B হবে না?
I'll have a look.
C হবে না স্যার?
I don't know. I did not solve them recently. So let's have a look. I hate it when this happens. Acha, ঠিক আছে. Perfect. So we want the current flow to happen from red to black, which means we want the red to be the positive, the black to be negative. So I'm going to first label all of this because I am trying to make the discussion. You might as well choose not to. Which means current has to be coming through this pathway and rise up in this way for all of the circuits. So remember that. Let's have a look. There are many different ways to solve this problem. I'm trying to show you the way that I personally feel easy to understand, not essentially the simplest way, easy to understand. This is an AC supply, so we have to consider the function of a bridge rectifier. And I'll tell you one thing that will make it pretty obvious for you to choose. For example, let's judge for the first thing. Let's consider that top's end is positive and the bottom end is negative. We're gonna do the reverse in a bit as well for the reverse cycle. Let's consider this first. So which means currently this is the high voltage side. Current is gonna flow through this path. It comes up over here. This is a diode in opposite direction. This is a diode that allows it. So it is gonna flow through this path, reach up to here. Follow করা যাচ্ছে কিনা? If you miss up at any point, stop me because you have to understand this thing. So current cannot go through here. So current flowing through this diode unrestricted coming to here. This is providing a restriction. So current cannot flow through this path. So current has to flow through the red and eventually come to the black and then it comes up over here. Now, once the current comes up over here, both of these diodes are open. But you have to understand, this is the high voltage side. This branch is the low voltage side. Let's come to the negative side. Current always flows from what? Which voltage?
High to
High to low voltage. High voltage into low. High voltage to low voltage. তার মানে হচ্ছে once the current flow reaches to this corner, this end, it is definitely not going to get back to the high voltage one because there is no point. So current is going to definitely flow through this path and eventually it's going to go out and eventually complete the circuit, which beautifully makes sense. So in this case, for this circuit of the flow, current is flowing from red to black. Works for me. If you consider the second scenario, let's say I'm going to draw that with blue maybe. Let's say if this one is plus and currently this one is minus. বলুন তোমরা কি সব আরোগুলো দেখতেছো নাকি আমি এইটুকু আরো জুম করব? দেখা যাচ্ছে?
Yes,
জি
sir.
স্যার দেখা যাচ্ছে।
That's okay. So if this is the positive and this is the negative. So এখান থেকে কি হবে? Current let's say এখান থেকে মুভ করা শুরু করলো, so the current comes up to here. Once again, it cannot go this way because this is restricted. It's going to definitely flow this pathway. So current rise up through here and flows down, flows from red to black. Beautiful. And current reaches up to this point. Once it reaches up to this point, both of these connections are open. But currently, this was the positive end, this is the negative end. Current will not go to the positive end back. So it will definitely travel to the negative end and it will eventually come back to the negative supply. So the circle is fulfilled. Which means for both the half cycles, upper positive, niche negative, or niche positive, upper negative, we are having the current flow flowing from red to black. Which means this is basically serving our purpose. A, in my opinion, is the correct response. Now I'm going to show you for the other three options as well. What wrong do they have? What wrong do they have? Let me show you. This is a 2-level supply. Let's say this is the positive, this is a negative. First, I'm showing you with blue. Or I actually might show it with red, brown.
স্যার
Follow.
স্যার এই রেড আর ব্ল্যাকের এখানে পজিটিভ নেগেটিভ কেন দিলেন এটা বুঝিনি
Because the question told us to find out the circuit in which circuit the direction of the conventional current is in the resistor always be from red to black. We want to find out the circuit in which the current should flow from red to black, which means red have to be the high voltage side and black has to be the low voltage side. That's why I did that.
বুঝছি স্যার
So if we have a look at option choice B, how does that work? Have a look. For option choice B, let's say this is the top end is positive, the bottom is negative. So this is the positive end, this is the negative end. Current comes in here, which is to here, cannot go through here. It is a reverse bias, opposite arrow path. So current is going to flow through here, so it comes to here. And it cannot go this way. And you can see it very well. Now the current is going to flow down and start to flow from black to red. This is the only pathway. I'm not going to go any further on this judgment of this circuit because I can see that even for the very first observation, can have to flow from black to red, which I'm not trying to achieve. So I'm not going to judge it anymore. I'm moving on from this one. বুঝছো কি? কারণ আমার aim ছিল কারেন্টটা করতে হবে red থেকে black এ। আমি দেখতেছি clearly যে if this is positive negative, the current can only flow from black to red. পরের টুকু কিভাবে কমপ্লিট হবে কি হবে না সেটা আমার জাজ করার দরকার নেই because I can see evidently this current flow has to flow from black to red, which is not my expectation. So I'm not going to judge this anymore because I know this is wrong already. So skipping this thing, coming to number C. Sure. Have a look at number C. Once again, let's label these and try to judge. Current comes in here, current comes to this point, this is a positive, and then this is a negative. Current flows through this pathway. And you see, once it reaches to here, this diode is now open. Do you see that?
Yes, sir.
This diode is open. And you have to understand one thing. If the current has to flow through the resistor, this is not the shortest resistance path because the current can very easily flow through this path and get back to the negative end of the battery. So there is a zero resistance path that is provided in the circuit, which is not supposed to be available in any circuit, but it just so happens within this circuit you have a zero resistance path, which means at least for this half cycle, current will not at all flow from red to black. It will not flow from black to red, but a resistor কোনো current flow হবে না because current will simply go through the diodes because they are all in forward bias and complete the circuit. This is a basic short circuit. So this is not having the current flow from red to black. I can see the error already. So I'm moving on. This is not acceptable either. As for the D option, let's try the same strategy. Positive and negative. Top is positive and negative. Current comes in here. Current comes in here. Current flows in here. Now you can see current could possibly go down. Current could possibly go this way. This is the negative end. In which direction is the current flow? Is the current go to the resistor or is the current flow through the diode? Which one is the least resistance path?
For the diode.
For the diode.
Obviously through the diode. Beautiful. So the current will definitely go, all the current will flow through the zero resistance path and usually complete the circuit, reach up to the negative end. No current will flow through the resistor whatsoever. So that's an error because once again, this entire pathway has now become a short circuit path. So this is also not acceptable. So ultimately, you only have this choice available. This is a correct response. So এখানে একটা interesting part হচ্ছে that for half the cycle, two of the diodes are working and two of the diodes are not working. Not working means current is not flowing through them. And for the other half cycle, the other two diodes are working and the earlier two diodes are not working. So for every half cycle, two diodes allow the current flow, two diodes don't. For the other half cycle, two diodes allow the current flow, the other two diodes don't. That's how the whole bridge rectification or full wave rectification works. The beautiful thing about full wave rectification, which I think this is not a part of the question, but I would like to show this to you. On the current circuit that we choose in V1, clearly indicate the arrows of the path of the conventional current in the circuit when the upper terminal is always positive with respect to the lower terminal. Also, we have already actually covered that in the question. Beautiful, it works for me. The one thing that I wanted to show you is that whenever we had, it is to calculate. Whenever we had, sorry, I shouldn't have done that. A second. Whenever we have an AC supply, which was connected with a single diode and be connected with a resistor like that, and this was our output side, this was our input side. The thing was, if the input was an AC supply like that, the output would be half the cycle. So if in any case, if you have to draw on the provided graph, you draw it like that. Eta hocche amader single diode output. But if you have a bridge rectifier connection like this, which is practically allowing both the cycles, but it is correcting the device. You see, irrespective of the cycle orientation in the source, we're always having current flow from red to black, which means if we have a bridge rectifier circuit, and if sorry, I should have drawn the, let's say this is the voltage versus time graph, voltage over time graph, and if this is the given supply, if you have a bridge rectifier, it will rectify both the cycles, which means both the cycles will become DC. None of them will be reversed back. বুঝাচ্ছি কি বলতেছি? It will be zigzag, it will have ups and downs, but it will always flow in a single direction. So this blue line that you see can be actually called a DC supply, because the idea of DC supply is that can always flows in one direction. Current is flowing in one direction. It is having different values, but it is always flowing in one direction. As long as it is flowing in a single direction. And also similarly, we can call this one as this blue line also a DC supply. Here the current flow is happening in one direction. For this direction, current flow is not happening. But once again, when the current flow is happening, it is still flowing in the same direction. So you are having the current flow, as long as it happens, always in the same direction. In some places, the current flow is not happening, but current is never flowing in the opposite direction, which means this blue line is a DC, this brown line is an AC. Similarly, over here, this blue line is a DC, the brown line is an AC. But the beauty of the bridge rectifier is that it will correct both the half cycles. এরপর এটাকে একটা সার্টেন মেকানিজম দিয়ে এটাকে আবার ফ্ল্যাট করা হয়। এই ফ্ল্যাট করার মেকানিজমটা আমরা এ টু টু শিখব, এখন এটা লাগবে না। বুঝা গেছে?
স্যার এই পার্টটা বুঝি না, এই যে হাফ কারেক্ট বোথ দ্য হাফ সাইকেলস কিভাবে বলবো?
When the top end was positive, then bottom one was negative. It was allowing current flow through this path in this direction. When the bottom end was positive and the top end was negative, it was still allowing the current in this direction, which means for this resistor, this side was always the high voltage side, this side was always the low voltage side. So this resistor experienced DC supply.
বুঝছি স্যার। Yes sir.
So
Yes sir.
এটা এরকম হয়ে গেছে। So the brown one is from the supply, the blue one is for the output or across the resistor that we have connected in the circuit. Question number 10 আমাদেরকে একটা NOR gate দিছে, NOR gate এর আউটপুট দিতে বলছে. This is basically the truth table. Read it carefully and you fill this up. And then we have that same thing, that we have multiple different input levels. You have to fill this up. You see, now we have once again a similar circuit, but you can see now the LDR is placed at the bottom, and we have all the resistors and the bulbs and everything, which means if the circuit has to work, this part have to have a large voltage. This part can only have a large voltage if the LDR has a high resistance. LDRs have high resistance when? Darkness or brightness? One.
So lightness.
LDRs have high resistance in darkness or in brightness?
Darkness, sir.
Remember, both of these two components, thermistor and LDRs, they are more or less less more. More or less less more means high temperature, low resistance, high brightness, or more light, low resistance. They work in opposite direction compared to the variable that they work with. So if you want this light to glow, you want a high voltage in the lower part so that this current can be significantly bigger. So to have a high voltage over here, this voltage have to be high, which means this LDR should be kept in darkness. So when this LDR is dark, this light will glow up. When this LDR is kept in bright light, this light will glow off. A practical use for this circuit is the street lamps. You're gonna attach this LDR on the top head of the street lamps, which is gonna take the signal from the sun. When the sun goes down, the LDR drops into darkness, they will light up the street lamp automatically. When the sun comes up, the LDR are in brightness, they will switch off the light bulbs. কিছু বুঝলা?
Yes, sir.
এটা ফাংশন বুঝে গেছে কি সবার?
Yes, sir.
আচ্ছা ঠিক আছে। এরপর আমাদের এরকম আরো অনেকগুলো সার্কিট আছে, এগুলো আমরা নিশ্চয়ই সালভ করতে পারবো, বাট the primary discussion which actually covers the whole thing, I've discussed this in that single circuit. এখানে আমাদের কিছু complicated circuit আছে. It's pretty interesting to work with. Although this is optional, but this is interesting in my opinion if you ask me. So I'll upload this paper to you. You can attend this paper at your own convenience. আর আমি একটু পর তোমাদের lecture upload করে দিচ্ছি. I'm going to stop the recording right now because class is over.